Did you know that without industrially synthesized ammonia, 1/3 of the human population would not exist today? Often referred to as the invention of the century, industrial synthesis of ammonia enabled the immense human population growth the last 100 years, providing enough food for everyone. But every coin has two sides. And the process used today has hardly changed the last 100 years. It demands high temperature, high pressure, and hydrogen as a reactant. But hydrogen is most commonly produced from natural gas, emitting about 1.8 tons of carbon dioxide for every ton of ammonia finally produced. And annually, 200 million tons of ammonia are produced worldwide. That means that 360 million tons of carbon dioxide are emitted to the atmosphere because of ammonia production every year. That's about the same as the emission from 100 million cars for 1 year. We, Atmonia, are developing a revolutionary new method to produce ammonia from air and water with no carbon dioxide release. And to add to that, it also occurs at room temperature, room pressure, and for lower energy demand compared to the conventional process. We built on 13 years of research. We have been founded by the National Grant of Excellence with Rannis, and we have been awarded by the University of Iceland. We have published articles in peer-reviewed journals because the last 13 years we have used quantum chemical calculations to screen the whole periodic system for surfaces capable of catalyzing the reaction of nitrogen from the air with water to produce ammonia. The last year, or now, we have found 4 best candidates for this reaction as catalysts. And we have an experimental setup, and we have immediately now started testing our catalysts. And the first results are very promising. We have founded Atmonia through the Startup Energy Reykjavik process. We estimate that we need about 3 years for catalyst testing and optimization to deliver a proof of concept in 2019. And then 4 more years for process development to be able to launch our product in 2023. For the first phase, we need to build a cutting-edge lab and be able to use or spend our whole time working on our research. For that, we need about $4 million. For the second phase, we want to team up with a large fertilizer producer for scale-up and process development to make sure that our process fits their demands and ease access to markets worldwide. But annually, ammonia is produced for the worth of $100 billion. So licensing our patents to market holders will immediately start returning benefits to our investors. We know that we are working in a very competitive research area, and there are scientists worldwide trying to find a solution such as ours. But so far, the Atmonia process is the most promising. All the others have at least one downside. They use hydrogen as a reactant, thus, as we've been through, emitting carbon dioxide. They need high temperatures or high pressures, or have very low yield, leading to very high energy demand. The Atmonia process will be the sustainable solution for ammonia production. And we have a patent for it. But the clock is ticking. Last year, 195 countries signed the Paris Agreement, promising to stop global warming. To be able to fulfill that promise, we not only need to harvest renewable energy sources, but we also need to redevelop all known energy demanding and polluting processes. The Atmonia process will be the sustainable solution for ammonia production worldwide. This is the Atmonia team. We have Professor Egil Skúlason. He has been working on this project since he started his master's degree the last 13 years. He has a PhD in engineering physics from DTU, and he is a professor at the University of Iceland. I am Dr. Helga Dögg Flosadóttir. I have a PhD in experimental physical chemistry. I'm an employee at the Innovation Center Iceland, and I jumped on board on this project 4 years ago because it's just way too exciting not to participate. Arnar Sveinbjörnsson is writing his master's thesis now in engineering physics, where he designed the experimental setup that we use to test our catalysts. But we are not alone. We have a team of 13 experienced and highly skilled scientists and researchers working with us. And we have the University of Iceland and the Innovation Center Iceland supporting us all the way, and good collaborators in grain research who are leading scientists in material design. We founded Atmonia because we know we can use our knowledge and our experience and research to contribute globally towards a sustainable future. Thank you.